Hey everyone, we are going to be talking about lesson 17.1 today. And it is in the book, but I'm not necessarily going to make you open up the book today. We are going to do a note sheet instead. Okay, it's called Solving Systems of Linear Equations. And this lesson is all about the graphing method. So we are going to solve a system of linear equations by graphing. Notice it says equations, so we are going to have equal signs again. So there's going to be no shading. And then we're going to interpret the solutions of a system of linear equations. So how many solutions does it have? What is the solution? And maybe what does that mean in terms of our story problem? So on this note sheet, systems of equations are two or more, and we're just going to start with looking at two. With the same variables. And normally, those variables that we use are x and y. So for y equals mx plus b. Graphically, the point x comma y, where the two lines intersect, that would be our solution or our answer, the intersection point. The solution algebraically is the point x comma y that makes both equations true. So when we plug them in, we get a true statement. So there are three different types of solutions. Okay, this first one is intersecting lines. So if my lines look like this intersection point in the middle would be my solution, and that means there's one solution. And we write our solution as x comma y. So they could intersect at 1 comma 7 or negative 2 comma 4. If we have parallel lines, think back to what we know about parallel lines. Parallel lines have the same exact slope, the same m value, and they never intersect, they never touch. So there's going to be no solution. So you can write it like this, no solution, or you could write no, SOL, and abbreviate. No solution because they never intersect, they never cross, they never touch, because they're parallel, they have the same slope. Then, if it happens to be the exact same line, so it has the same slope and the same y-intercept, they're right on top of each other, and that means we have infinite solutions. Or we've abbreviated before as IMS, infinitely many solutions, or you can use the infinity symbol, whatever you prefer, however you want to write it. There are three steps that we are going to write down in order to solve systems by graphing. So step one is to convert to slope-intercept form. And if you need to, you probably have room, you can write down that slope-intercept form is y equals mx plus b. Okay, or to convert to slope-intercept form, we solve for y. And that's only if necessary. So if it's in standard form, we have to convert it. Next, we're going to graph both lines. And then lastly, step 3, we just need to identify the solution. So state how many solutions it has from above. Question 1. If I'm looking, both of these are in slope-intercept form. So the first one is y equals x minus 8. So what we're going to do is plot our y-intercept first, and then use the slope, the m, to plot multiple points. Now, if I don't have a number in front of the x, we're going to assume my slope is 1, or 1 over 1, which means my rise is 1 and my run is 1. And think about Mr. Slope Dude. Remember that if you have a positive slope, your line needs to be increasing from left to right. And if you have a negative slope, your line needs to be decreasing or declining from left to right. So this is a positive slope, so I'm going to go up 1 over 1. So that my line is inclining or increasing. And then I want to go down 1 over 1 the other direction so that I have multiple points covering my whole coordinate plane, covering my whole graph. Now you're going to use your ruler and connect these points. You want to use a ruler or line up something that's straight and then connect them. Maybe put the straight edge of a book, something straight down. We need straight lines so we can see where our intersection point is if we have one. The next graph, I'm going to use green. It's y equals negative 2x plus 1. So we're going to start at a y-intercept on my y-axis of 1. And my slope is down 2 over 1. It's negative, so it needs to be decreasing or declining. And I have found my intersection point. The blue and the green intersect the two lines. Again, use your ruler to connect them. We want our lines to be perfectly straight so we can tell what our intersection point is. And it looks like my intersection point is right here, so that's one solution, but I need to say what that ordered pair is. X is always first, just like the alphabet, and then Y. Remember, we have to go in and out of our elevator on our x-axis. So I went over 1, 2, 3. So my x value is 3. And then after we go in and out of the elevator, then we can go up and down on our y-axis. So then I went down to negative 5. In between negative 4 and negative 6, the negative 5. So my one solution, my answer is 3 comma negative 5. That's the intersection point. And we're done. Okay, let's take a look at question 2. Step 1 says to convert to slope-intercept form if necessary, which is y equals mx plus b. But if I'm looking, they're already in slope-intercept form, which is nice. So I'm going to graph this one first. This 9 here is our b value, our beginning point, our y-intercept on our y-axis. So let's go up to 9. And then our slope is positive 1 over 2. So this line needs to be increasing or inclining. So up 1 over 2. And I can't go up 1 over 2 anymore. So let's go down 1, left 2. Down 1, left 2. And use your ruler. And connect the points with a straight line. My second line is y equals negative 1 over 1x plus 6. So plot our y-intercept first, b value, which is 6. And then my slope is a negative 1 over 1. So I'm rising 1 and I'm running 1. And because it's negative, this line needs to be decreasing or declining from left to right. So I'm going to go down 1 over 1 this direction, but I know it's not going to intersect anywhere down here. So then up 1 over 1, up 1 over 1. Go ahead and use your ruler, your straight edge, to connect your points. And I see that these two lines intersect, so it would be one solution at this ordered pair. X, Y. So on my x-axis, I went left to negative 2. Does everyone see that? Point, coordinate point is at negative 2. And we went up to positive 8. So negative 2 comma 8 would be our solution points. So on the back of this worksheet, you are going to see questions 3 through 8. For question 3, both of these are not in slope-intercept form. So we want to convert them to y equals mx plus b. And we've been doing this since activity 12. Okay, so you're all rock stars at this. You just need to isolate your y. Get your y by itself. So you're moving your x's. So you're going to add your 3x. So y equals positive 3x plus 8 would be the first line that I'm going to let you graph on your own. Your second line, you're also adding your x value in order to get this y by itself. So I need to add x to both sides. And y equals positive x minus 2, because it was a negative 2. So graph this first line. It has a positive slope. It's increasing. Your second line also has a positive slope, so it's increasing. And then say what your solution is. Now, in questions 3 through 8, all of your intersection points are going to be whole numbers. So there's no fractions or no decimals. It's going to be a perfect intersection point. There's going to be one question that has no solution, which means your lines are parallel. And there's going to be one question where it's the same exact line. And if we look at our notes, that means it has infinite solutions. So go ahead and finish this worksheet. You can do it.